Hi everyone, welcome back to our channel. Today I would like to show you how to do the symbol of the network. We use the dataset from the function init from the TOS region. First of all, we have to import the library. So we do the import TOS, import .nn. I will explain you later when we use the library. So we just import some of the library we need for the training right now. So Optis is for the optimizer. So when we do the training, we need the optimizer, and from the TOS vision. So we got the TOS vision here for the import the data set and transform. And next one, we have the data loader. So we have to import the data loader. Data loader. Okay, after we done with import some library, so we need to do the data set and pre-processing. The function init is the you can get like 60,000 of training in May and 10,000 in May for testing with the rate scale in May, so 28 times 28. So before we train, we have to put the dataset into our format like tensor, and then do some normalize to shift the scale to around -1 and 1. So to do this, so we do the transform. To compose. So this one, transform to tensor. First of all, we have to put every in May when we put inside to tensor format. Transform, I think it's S here. Yeah, transform to transform format. After this, so we have to do the normalization. So transform dot normalization to make sure then may shift scale roughly -1 to 1. So 0.5, 0.5. Okay, done of the data pre-processing. And then we have to load the data sets. So this we have to load the data set into our train data sets and test data sets. So we live in, they already sleep inside there, so we don't have to sleep. So we just load the data sets. So train data set dot function init. So we go to root, I call data trend equal to, so we got 2 and transform equal transform download is true. So after we run this, so they will download into our root with the folder is the dataset. Same thing with the test. We have to download the dataset to the dataset equal dataset function. I need root equal data test train font. So we don't need train this one, so that's why we set the train it font, and then we apply for the transform. So we already define the transform above. So okay, so after we done this, so we run it, so we got the data will like loading into the data set. Okay, we're done. So after that, we have to wrap the data set with the data loader and choose the batch sample like batch size. So how we then do that? We do like train loader data loader like data set equal train data set. So we put the data set here and batch size 64, and I put the batch size 64 here. You can put like smaller depend on how data sets. So suffer 2 is suffer is here. So when every time we put the batch size 64, we cannot put all in May into the model, so we have to decide the batch size to every step to put inside the model, like 64 in May into the model. And then when we run all of the in May, so they will like return for the first one, we change another epoch. So the software is means, so we don't want like every time like the same in May to put inside the model and the model not learning. So that's why we have to do the suffer equal true. So that's one the new epoch they will suffer. They make the model, they make the data set diverse and the model can learn. Same thing with the test loader. We have to define the data loader. Data set equal test loader and batch size equal 64, transform equal transform. Okay, so we don't need transform here, so we just need suffer equal 4 here. These are the test, test data set. Okay, so after this one we got the data loader, so everything ready for the train. We got the data sets, train data set, that data sets, and we got the train loader, test loader. So next one we have to define which model we use. So we want to use the symbol of neural network right here. So we have to decide class simple neural network. So NN is the heritage, the object oriented. So we inherited the model from the neural network, and then we decide the functions in it. Function self. So we have the two functions. In the first one, we have to init the function, so define how many layers inside, and then the next function will be the forward. The forward function is to connect all of the layer inside. So just simple like that. The first thing you have to init how many layers inside there, and the next function is forward to connect all of the layer. Now, first of all, we have to support just like the function to inherit. We call the function here and self. We have to init. Okay, so we're already done with the function. So next one, so before we flatten all the inmate inside. We have to flatten self, flatten. We flatten up inmate before we put into the neural network for the fully connection layer. And then we got the first fully connection layer is we have to divide it. We divide the three layer, right? Fully connection layer inside with a linear. So for the MNIST, so we have the input layer is 28 times 28. We decide output layer is 64. And next one we have to decide for the second layer. So remember, it's the output layer 64. So when you put inside the second fully connected, so the input layer must be 64. So 64 here, and the output layer. So you can decide whatever the output layer. Usually we use the power of 2. So each one you can use like 64 or you can use like 32. So we have to I choose the 64. Okay. And next fully connection layer, the last one. So also 64. The last output is a 10 because we init with the 10 classes. So we got a 10 for the last output. Okay, so that's all for the init function. So now we have to connect all of the fully connection layer together. So we have to like edge self, same thing, we have to flatten. X, so the X put inside and then we flatten it. X. After we flatten, we have to connect into the first layer. We use the activation function is reload. So how they work it here, so when the inmate inside here, they flatten the inmate. After they flatten, so they go we go from the right back to the left, so they go to the fully connection layer, and last one they activate use the activation function reload, and then we put inside the is again. So the next layer, same thing with the reload cell dot fully connection layer 2 and X, the last one. For the last one, we don't need to activation function because the last layer we got the output at 10, so we use the submark to predict so what is the higher of the maximize of the probability. So we don't need to use the reload. So that's one, just cell 3 and X, and then we return X. Okay, that's all for the simple neural network. So everything done. Next one, we have to declare the model and then do training. Before we training, we have to define some of the loss or optimizer, which one we use. So first of all, we have to do the model, simple, and then we call array class here. So we got the model inside here. So after we have the model, we have to define the loss function. We call criterion loss entropy loss, and then we have to define the optimizer equal of this. We already define the library ops there. We use the Adam to use the optimizer. The model dot parameter and learning rate. You can set the learning rate 0 or 1. Okay, so after the learning rate, optimizer, model, and a load function is set up. So the first thing we have to set up the device use the CPU. So we got a device dot device. Okay, we use the CUDA. If dot CUDA is available, we use the CUDA. Else we use the CPU. Okay. Okay, so after this, the model, we have to define the model use the to divide. Okay, the model to okay, everything set up done. So now we have to train it. Call a training loop. So we have to, first of all, we have to divide the number of the epoch. So we got the number of epoch here. We have to set the number of epochs like 6, and 6 epochs. So so we go to epochs in rank, number of epochs. So we have to define where the model is. So the model is in training. The different the model training, because the model work differently from the training or from the evaluation. So that's why we have to declare where the model is. So model right now in the training. So for image label in train loader image label equal image dot divide. So we put the image into the GPU. Okay, done. So we have to set the output. The model image. So everything the output done. After the model give me some output, so we have to do the loss. Criterion. So we already set up the loss criterion over there, and we use the output, and we use the label with 2 round label. Route 2 labels, and then we have to do the backprop, so parameter update. So we got the optimizer dot 0 rate. Why we have to do the 0 rate? Because we don't want to, like, we clear on of the radian, the clean on of the radian. We don't do any like update of radian. And we do the loss dot backward. So we can move the new radian. And then we do the optimizer step. We update the weight. So after this, so we print out the epochs. Epoch dot 1 divide for number of epochs. And loss. Log dot item. Unit for floating number. Okay, for that is for the training section, so we have to let the model know it's now is turned into the evaluation. So when the model go to the evaluation, first of all we have to do with toss dot no rand again, so we disappear the training specific layer, and then we memorize the effective the fast in front. So last one we got the toss with no range. And we set up the two variable like correct 0 and total equal 0. And same with the training section, we have to declare label in my in range in test loader in maze label equal in maze to divide label dot to divide, and then we got the output model in maze. Okay, until here we got the training and evaluation, exactly the same here. So for the evaluation we have to make a predict, right? So after we got the output, we make to predict like predicted equal toss dot match output dot data equal 1. So that means we have to explain the toss mask. If you put the output in 0, it's the mask over dimension 0. So if you put the output is 1, it's they have to calculate all of the like probability. So for example, is we have the 10 classes, and then the probability for each class for this number is different. So we use the toss mask to choose the higher mask for the output. And then we total like label size and last one we have to correct predict equal label to sum all of the correction together. Next step we do the accuracy 100 time correction correct divide for total. And then we print now the last one, we print now of the results. The test accuracy accuracy. We now with the 2 float number, and then let me train it to see how this works. Yeah, got it. The first epoch we got the loss 0.5 for the test accuracy like 78%. It's quite good for the first epoch. Yeah, the second epoch you can see the loss decrease, so that is the good side, and then the accuracy is 81. It's quite good. So let me the test epoch, so we got the loss entry a little bit, but the accuracy is entry too. It's quite good for the fourth one. Okay, so after the 6 epoch we got like the loss from the 0.54 go down to 0.27, so it's quite good. The accuracy from the 78% go up to the 84.52%. It's quite good. So that's it for the simple neural network. So I hope you enjoy the video. Thank you. Bye bye.